Okay, please go ahead.
So for person.cpp, you tell us to get the code from the internet, and we use it for the function get geodata source distance, but that one is not in the interface. So do we use it for the distance, the double GPS underscore DD distance? Do we use that function to complete that one?
Yes, but with very slight modification. Okay, with very slight modification. Let me go back to homework assignment part 2 here. I don't want to show you the answer, but I want to show you the one you received. Okay. Let me be specific. Emacs person dot H or CPPH. Let me use the H. So in person, where is the distance? Where is the distance?
It's not in the interface, it's only in the CPP file.
No, it is. It is here. Is in this file, this distance, right? So
Yeah.
in the GPS, I have this interface called distance, right? And then in the person.cpp, I have, let's go to that distance first, right? So this is the distance I supposed to implement, right? And the thing is that this needs to call another function called geodistance, which I put the function prototype here. In fact, what you really need to do is that you are going to use this link to get the C function to implement geo data source underscore distance, and then have that function be called inside here to implement this part. Okay, so in some sense, this in my answer, when I implement this, I only have like a one line here. It's a bit long, but it's a one line. And then I essentially copy the code from that from this side and to put in over here. Okay, the reason I kind of changed name geo data source is because the function in that code is called distance. And I don't want to confuse because I might be over. I mean, it's doable because especially in C++, I can do overloading. It's doable, but I just don't want to confuse you. That's why I renamed their function distance into geodata source, because I also want to recognize that that distance is actually developed by the company called geodata source. So let me now go to the place and just illustrate what I meant by why I'm changing the name. So let me actually go here and okay. So this is the code from what I show you. That I already include this in the CPP file, and I already include the code for this two supporting function as well. And you can see that this is really the part, right? This is really their prototype. If you look at this prototype here, the prototype here is exactly the same as the prototype I provide here, right? So the only difference between this line and the line I show you is the name of the function. I add this part to the name of the function, and the rest are exactly the same. And you basically just using this one, and it will automatically create the distance. So this part is the code you need to essentially copy and shuffle in there, and then figure out how to use this code in the .cpp file. Does that answer your question? Yeah, go ahead.
Well, like also, how does that function is different from double transaction get distance? Since in transaction we have members of object GPS and person. How do we implement? How do we use
Okay.
a function from
Okay,
that one?
that's a good question. I will try to give you hint, but without telling you everything. Okay, you have to figure out yourself. So now let's be clear that let me see, control. So now you know how you can implement this distance function under the class GPSDD, right? So now let's
Yes.
make sure you understand that. So the semantic of this is that if you give me the another GPS DD object as a input argument, then I'm going to compute my own distance with that GPS DD you just input. So this is what the distance function is basically trying to provide the distance between two GPS location, right? Okay, so now let's go back to transaction. So under transaction, there is a function called get distance, right? There is a function called get distance. And the thing is that if you think about that, the distance is between these two GPS location, right? Source and destination, right? Because inside transaction, you have two. So essentially, what the implementation of the get distance is that using one of the GPS DD object to call their distance function and put the other GPS DD object reference as the input argument to that function. Then you implement the result from that distance function will be the result of this transaction object as well. Does that make sense?
When I try to do that, I get an error that says, give me a second. It says a non-static member reference must be relative to a specific object.
Okay, that I think is it could be a syntactic error. Do you want to do you mind if you share the you know what I prefer
I don't
not for you
mind,
to
but I
share
already
here.
have some code written on there, so I don't know if that'll be like.
No, I'm just struggling. On one hand, I really appreciate your willingness to share, but I hope other students will experience the same thing you experience and learn from that process. So I would rather for you and I to exchange privately, which I can help you, and other students will struggle the same way. Some of them, not all of us, but they will interact with me as well. I think it's important to help not just you but help others as well. So I think my the thing is that I do want to say is, to me, the reason you got compiler error, you can see that sometimes I just show you the example. I just took out the parentheses and the compiler doesn't like it, right? And it's sometimes the computer language is very, how do I say that, very delicate. It's not like a natural language processing where tolerate a lot of differences. And computer language is totally strict and very intolerable. And therefore, sometimes it's just one small thing. You forgot to add one sign, or you forgot to do this, and is the compiler will just complain. So you might want to look at the message given back by the G++ compiler and see which part is talking about right-hand side or left-hand side, or they're talking about which object, and maybe sometime the variable name you thought you're using this variable name, but you didn't provide a this, or you didn't provide TRSRC where. Are you accessing those variable correctly? And the compiler sometimes just not recognize what you put down. And the thing is that learning programming language, a lot of time we waste is just to learn the precise linguistics, what computer really like to have. So seems to me that conceptually you're getting the right thing, but you only just need to learn the linguistics to interact with the compiler. Okay, so I would recommend you to try yourself a little bit more, but you still stuck, just send the way you write the code and the way you got the error messages sent to me via Facebook or email. By the way, for those of you who send me email, I haven't responded. I'm kind of slow in getting back. I realized that I actually respond more responsive using Facebook because I open the Facebook window all the time and beep, beep, beep come up. I have to deal with that. Okay, and the email is quiet. So that's why it took me a while. But I promise I will look at all the email as soon as possible. Okay. Is that okay with you? Is this Aldo?
Yeah.
Okay.
Or do you think it has to do because in the GPS class we have the function distance, and I'm trying to use it in the transaction class since we're not inheriting? Is it that the
It's
problem?
okay because I think there's no problem with this because under transaction I have a variable called TR-SRC where, right? It's the class
Yes.
GPSDD. If I now look at my person.h, if you look at the definition of the class GPSDD, that this function distance is being declared under public, right? So it's a public, so I
Yes.
can just, let me just write a small second of code here, but it just tell you that how I'm going to do it. Assuming I'm inside the transaction object, I will just call this to the tr src where, okay, this represent that I reference to this particular variable, and I will usually just put a parenthesis to just make sure that the compiler is parsing things correctly. And then I would just say dot distance. And then I have to provide some variable here. Okay, this should work. This is the way for me to, inside the transaction, I want to call the variable. I mean, because I'm inside the transaction, that this is a private, right? This is a private to transaction. So I'm inside the transaction, I can do this. But to this as a GPSDD, this function is a public. So I'm getting the pointer from my internal transaction. I'm calling this public function, and that should work. Is that
Yeah,
somehow?
I'll try that because I was
Okay.
just using like the this and then tr source where, but I was using the dot get latitude dot get longitude.
Oh, I see what you're doing.
I was trying to do it that way and then use the geodata function to calculate that way, if you understand what I'm saying.
No, I understand what you're saying. I understand what you're saying. Yeah, you can do that as well. I think you can do that as well. But let me think. I think that should be okay. That should be okay. You just call you call essentially the function, right? The geo whatever underscore distance and provide 5 parameter into that. You get that number. That should work as well.
Yeah, so that's what like my original question was like, what's the difference between this get distance and transaction versus the one in the GPS? Are they like really the same? Because they
They're
both
they're
take in
really
longitude and
they're
latitude.
they're really the same, but it's a different way of calling it. If you directly call the function that's provided by the web link I sent to you, it's okay. You just need to provide 5 parameter. You go in and then you can get your number, right? And the second way to do it is you actually directly call the GPS they provide. It's just one extra layer of abstraction, and whether it's necessary or not, but it's a different way for you to essentially, the bottom line is eventually you're going to call that function, right? You're going to call that function that we copy and paste from that web link. It's just saying that, well, how you think is the best way to represent your idea, the most readable. There's no one single answer is going to be the optimal or correct. It's really this is kind of the art instead of the engineering about how you write a program, I would say. I mean, in my opinion, I like the way to do the ways I mentioned in this. Is just because I think I can just describe some concept which is straightforward to my personal thinking. But on the other hand, other people might have a different way of they think that the other way may be more natural. So in some sense, it's a little bit no perfect answer and no standard answer. I shouldn't say not perfect answer, standard answer to that. But as long as the compiler says okay, then you're okay. All right. Does that answer your question? I'm sorry I didn't answer completely, but just based on my experience. Okay.
Yeah, that was helpful. It made it much more clear. Thank you.
You're welcome. All right. Any other question?
Professor, I have a
Sure.
question about the PowerPoint. Can we go back to the constructor part for the PowerPoint?
Sure. Okay. Yeah. Let me go back this way. Right. This one.
Yes. So in one PowerPoint, there's the output of these three different constructors, like copy and movie. I believe it's about 22 or 23.
Sure. Okay. Here. Yes.
Yes. Yes. So for this one, my question is: so in the for data C, you use the move constructor, right? So the value in data A is moved to the so the value 111 is moved to 333, right? So the third time you call in move constructor, the data A should be empty, based on my understanding, but it says 333, so I'm a little bit confused.
Oh, okay. So, okay, sure. Of course, I can explain that part to you. Let me use my program. By the way, I'm sorry, I should actually share this program with all of you because this is just a program I haven't got a chance to put it online. And then if you look at the program, it will help you to understand. So let me copy the .cpp because I make some changes. Discussion .cpp. Okay, I save this copy. Okay, so this is the code that you're referring to. So I'm going to remove those few lines that I just added because of the class. But this is the original code. Okay, where you're seeing in the on the slide. So let me explain this code this way. So one of the things I should say that in order for me to show the power of move constructor, I have to change this to pointer. So if you look at the original slide, that this is actually integer. If it's just an integer, it's just a value. I cannot show the power of move constructor with only this construct. So I actually changed this to PTR. So imagine what you have as a data is an object. Inside this data is the only place that's actually is a data part about this data object is a pointer. It's not a value itself. It's a pointer to another integer. So now I'm going to specifically talk about the difference between copy constructor and move constructor. As you can see that in the copy constructor, which is this part, that what I did here is I actually create a new integer using new to create an integer. And then I basically copy the value I got from this argument, a data, and I copy the value, not the pointer value, that into the value of this pointer pointing to. Okay, but here is very different. I just copy the pointer itself. So the difference between these two is this one is copy the value. This one is not copy the value, but copy the value's reference, the pointer. And therefore, the things I want to show the difference is that once you declare A, B, and C, so when I change the value of C to 333, and because A and C are sharing the same memory location for that value, and therefore, when I change one, I'm actually changing the other as well. So that is the difference. But in order to show you this, I want to show you another thing which is interesting. So let me write it down different way about this three thing. Okay, so I'm going to print out, instead of print out the value, I'm going to print out directly the address. Let's see what address looks like. Okay, if I get rid of the star, I'm going to see the address, okay, of that value pointer. Let's see what happens. Okay. Okay, you can see that this is exactly what's happening right now. I call default constructor 0 copy constructor. I must remove one line for 111. Sorry, I removed that 111 line earlier because of my previous demo. So now after I call this move constructor, and now this is correspond to this part. Okay, have you seen that when I print the address, you can see that A's address is the same as C's address because you're using move constructor. And therefore, why this has become 333 is because when I modify C's value, it's really modify the content about that address. So because A and C are sharing the same memory, and therefore they both get modified. But on the other hand, B is not. B is a copy, and the memory address is different. And therefore, when you do that, you're not affecting B's value. You're only affecting A's value. Is that better clarified what's going on in the example?
Yes.
Okay. All right, good. Any other question?
Can you talk about what's the difference between the and sign goes with the data type and it goes with the variable?
Okay, let me, in that sense, hold on one moment. Oh, I don't want to do this. Hold on, well, let me do this. Let me exit this first. I now need to go to my earlier program. Okay, so we talk about this part, right? Were you in this part when I talk about this example? Is this
Yes, I am.
is this Kali?
Yeah.
Okay. Were you here when I talk about this example about data A, data MD, and data MMD?
Yes, I am. But
Okay.
I'm just a little bit confused.
Sure. Okay. So in C or C++, there are two-part declaration. So for example, if I have this one, just look at this line, data and A, right? Just look at that line. There's two parts. One part is the type. It's a data type or the class type. That's the data, right? That's the data means it's represent the type to a variable, which is the A represent the variable. So in programming language that we have to have a way to separate these two. One represent the type, one represent the variable we're going to working with, okay? So if we understand this separation, then what we want to do is that when we add the and sign to our program, we need to ask ourselves whether that and sign is associated with the type or is associated with a variable. I think that is the critical issue we need to deal with here, okay? So for example, if I look at this code here, look at this code, data and D, right? I mean, do I know this and should go with the D or should go with the type? Because it's very different, because if I go with the data, that means it's just represent, it's a reference to, so the way if I do this way, okay, I do this way, in fact, I should actually do this way. So by the way, for those of you who are unfamiliar with C and C++, in C and C++, your code should still run if I, how do I say that? I should be careful about this, is that you can put this in, oh, can I do this? Let me actually try it. I could be wrong. Okay, let me try. Sorry about that, Colleen. I want to run the program, make sure I'm not talking something which is not correct.
Yeah, follow.
Okay. Let me actually see this. If I put, can I put this sign there? Oh, I can't do that. Okay. Okay, what happens if I do this? Can I do this? Oh, I can do that either. How about if I do this? Without any space, can I do this? Oh, wow, I can do anything like that. Okay, good. So my theory is probably correct. Is that in C and C++, the space sometimes is just for readability. The space is not being captured in the compiler. So the space is only used when you, the compiler can do the separation between data and n. For example, you cannot do this. This space is necessary, not this space. This space is necessary. You cannot do like that. Data and A. I think this one I'm going to get compiler error. Yeah. No, now I got compiler error. So space is only used as long as I can differentiate between the type of the data variable and the variable name itself. Then any other space is, it doesn't matter. For example, data n here, D, because I know clearly data and n has to be separated, so I won't confuse between data m and the D. Okay, that is just number one issue. I want to take care of that. Okay, all right. So now the issue is that you know that I just show you, you can put n with space, without space, space one side, space the other side, it doesn't matter. But now the critical issue is that should this be read as a readability as this way or this way? Okay, can you see my code? So is whether it should be this way or this way. Let me ask everybody here, do you think based on the way we write the code, which way is correct? Is number 1 or number 2? Which way do you think is correct? Is better or clarify? In other words, to actually do this is that I can always put parentheses, right? I can put parentheses, or I can put parentheses this way. It's probably put parentheses this way, it's better. If I do this, do you think should be number 1 or number 2? Which one will be the right one? Which one will actually get compiler error? Anybody want to guess? My guess is number 1 is okay. Number 2 is not okay. Okay, let's try. So that's why my always I'm saying that run the program and find out yourself, right? So I'm comment the second way first and do like this. Oh, it's not. Ugh. So I was wrong. I was wrong. It's actually the other way. Data cannot be assigned because it's copy assignment is explicitly deleted. Let me try the other way. So I was wrong. That's interesting. If I don't have this, I do this. Also not right. This is interesting. In either way, it doesn't like this. Okay, so I know the second way is definitely not working because my experience tells me that this won't work. But I want to make the first one to work. Why this is not? So if I do this, will that work? No, it's still not work. Wait a minute, did I do something wrong here? But this way will work. This way better work. Yeah, that's very interesting. Huh. Hey, Kylie, you just asked the question that I don't know the answer. So I'm still trying to figure out myself because I think my theory is wrong when I try to associate the data. If I write the code here, everything is okay. But I do otherwise, it will give me, the compiler will not like it. Why this one won't work? Did I work? Will this work? Okay, this way works. So okay, so for Kelly and other people, it's interesting. I know the D variable is I can isolate that. That's okay. I can put parentheses. I say this is a variable. I know that M sign is definitely not associated with D because if the M sign associated with D, like this way, this represents D's address, and this is not intention of the code. And M sign D as address cannot be shown on the left side like this way. You cannot show on the left side because the value, it has to show on the right side. And also D hasn't been created in any way. But what I don't understand is why I cannot do this. Oh, I know why I cannot do this. I know what I cannot do this. Okay. This one is arrow. Okay, that's fine. That's fine. I know why I cannot do this is because its compiler is thinking I'm doing casting. So if I do this, it should be okay. In fact, I can do this. It should be okay. Wait a minute. It doesn't allow me to do this. Okay, I cannot do casting. Okay. Okay. My best guess to the class is that whenever I do I think my understanding is still correct, but the compiler have some special association with the parentheses here, because when I do this parenthesis like what I did before, it's treating that as the casting, because right now I'm not doing casting. I'm just trying to declare a variable. That's why I cannot do that. Okay, so okay, let me wrap everything I just said. If you put an M sign here, this is on the left-hand side of this assignment. So this M sign should be associated with the type, which is the data. So this should be read as this way. Okay, that's the type. I try to put it far away from the variable, but doesn't matter. Compiler won't care about the space. It's just this as a type, which means that it's a reference to an object of data. Okay, that's what D is doing. All right. Well, then in what situation that you can put M sign in the left side is like this. You see that this M sign on the right side, on the right-hand side assignment, and it's actually when you do MA, this basically associated with a variable means ACE address. And I actually print out the ACE address for you. Oh, actually, I can do this to just show you a little bit about this. Let me get back this way. And I can also do this. And I can do MA directly. I think this is doable. And you can see that the address is the same. Okay, so that's the MA, because anytime you're not doing declaration or define a variable, M is associated with a variable. So it's confusing, I know, that they're using the same symbol, sometimes the reference associated as a type. It's a different kind of type. It's a reference type. And sometimes they use that to get the address of that variable. I mean, C is probably the only language that have this mingle these two together, unfortunately, or C++. Okay, is that give you some better idea about the M sign and in the C++ context?
Yes. So the N sign goes with the type. Is just about like the reference of the object, right?
That's correct.
C is the
That's correct.
reference of object A.
Right. It's a type. By the way, the M go with the, like in this case, go with the data. Is you should read data M together as a type, as a data type. So that is just the data. That's why sometimes I can casting. You see this? This is I can casting. When I do casting, this is the type, right? Casting means that I change the type of a variable or an object from one type to the other, because this type was data M, and I casting with data MN. That means this type has been changed in this particular statement. So then I can assign to another variable which is the same type.
Can I ask, what is the term reference mean?
Reference. What's the term reference means, right? I just want to make sure I understand your question. Is that right?
Yes.
Okay. if we are not, I mean, just I want to clarify this because some of our students are actually from the C world, okay? And some of our students never learned about C, and some of the students learn both C and C++. So there's some confusion over here because the reason I kind of paused to do this explanation, because reference, the word reference, means differently in C and C++. In C++, reference means something different, but in C, it's just the pointer reference and the address. They're the same thing in C. But in C++, now pointer still associated with address, sort of, but reference means something else, okay? Okay, let me actually, having said that, okay, I'm going to carefully explain what the word reference means in C++. In C++, reference means that it's a referral to a particular object, which means that if you want to access the object, you can access through the whatever the initial variable that the object created, but now I have a second way for you to access the object. In this case, D is a reference. So first, if you put D anything percentage like this way, then D is a reference to A. That means you want to access that variable, the memory location. Okay, let me actually say this. So A, when you declare this, you're actually allocate a piece of memory. All right, so when you do the first statement, you allocate a piece of memory. And now D is a reference to the same piece of memory. So which means that if I print, that's interesting. If I print MD, I might get a different way. Okay, so I'm not going to do this right now, but I will tell you. But D is a reference. Using D, you can reference to the same piece of memory of A. Okay, so this is just a reference for you to reference. And now I'm going to give you another variable. Let me pull out this one. Now actually, let me pull this one. So now I have A and D and F pointer. Okay, the first two are the reference for the C++. Sorry, this one is actually C++. I will call the C++ reference. And this one, I would say FPTR is C reference to the same piece of memory of A. Okay, they're just different way to access the same piece of memory, using this way, using this way, using this way. The only difference is that when you try to call it, okay, for example, does A has any member function? Oh, A only have a value pointer, right? So now I can actually access to this with a different syntax. If I want to use A, I just say A dot value pointer. Okay, this is the way I access to a variable using this, right? But then using D, I'm also doing the same thing. Because as a reference, I can use the dot syntax. But F pointer, I cannot do that. F pointer, you do this way. You use this sign to say value PTR. Okay, so it depending on how you define the reference. Is a C++ reference or it's a traditional C pointer reference, you can do that. I mean, it's a different way to represent that reference. But the thing is that when you want to use this reference to access the memory location, there is a difference between D and F. Okay, so that's basically multiple way of doing the same thing. Is that
Thank you. Yeah,
okay?
that makes sense. Thank you.
Professor,
Yeah, go ahead.
Reply. So in C, if it's the asterisk star, that's the address. Reference means address. But in C++, the reference mean, what's reference mean?
Okay, it's a similar idea. Okay, so this star, in fact, I'm a little bit misleading. This star should go with this. Okay, the same thing that when you see that star sign, is that star sign should associate with the type, or should be associated with the variable? This should associate with the type, because I'm declaring f pointer is a variable. The type is data star. It's a data star. So over here is representing that FPTR is the type of data star. Well, however, that you could do this on the left-hand side, I can say integer x is equal to star FPTR. Okay, I should do this. FPTR. So this is, I should actually say data. Data x. Let's use a copy constructor. Okay, so if I do it this way, that means the star is actually associated with FPTR. So while n, a variable name, represent is the address of that variable, star FPTR is referring to the value that the pointer is pointing to. So also you should see that whether the star sign is associated with the type or is associated with variable. Okay, so in this case, when I use star, this star in this declaration statement, that means this line here, this particular star is associated with the type data. But this line, when I go to here, then this star is associated with the pointer itself, associated with is a variable. Okay, so that's confusing, but always think about that way. Whether you have an M sign or a star sign, whether it's go with a type or it's go with a variable.
Oh, and data %, is that a pointer?
If it's data %, this is I said this is a C++ reference to an object data. So the other way, I want to just say that again here on my screen, that data % is a type representing a C++ reference to an object, to an object from class data. Okay, this is a way. And then I will say the data star is a type of reference, is representing a C reference or pointer or address to an object from the class data. I guess that is my
So data % is not a pointer. Oh.
Data %, is not a pointer.
Oh.
Because if it's a pointer, then you need to use this syntax. By the way, if it's just reference, you need to access reference this way. But it's a pointer, you reference this way. Yeah, so those examples hopefully tell you that what's the meaning of the declaration, of how to use those declaration that when you really doing the program. So for example, in ECF 36A, I don't think you need to learn this part, right? You don't need to learn about this part. But in ECF 36A, you should learn this part. This is the C reference to the same thing.
In the example you just gave me, the star goes with the F pointer, but now you move it to the data. Is it the same thing?
You mean this one? This line here?
No, the top one, the data start F pointer equals n signed A.
This one, right? This
Yes.
line, right?
Yes.
Yeah, this line, let me write it two different way, okay? So I can actually just write down like this. If I write down like this, that means it's just a reference to the, no, not this part, okay? It's just a C reference, right? It's a pointer, the type is going to store a address or pointer. But then you can do, after you declare that, you can then use a value fptr is equal to ma. Okay, you can do like this. You can separate it. Yeah.
Oh, but I mean, can you put the start just next to the F pointer instead next to the data?
Okay, you can do that, of course. You can do this as well. Because you can do either this way without space is okay. You can do this way is okay. You can do this is okay. I mean, with or without space is going to work. Compiler. However, I prefer to do it this way because that star, because it's really associated with the type of the declaration. That star doesn't associate with a variable, because if you associate a variable, you actually talk about the content about the FPTR, because we're not talking about the content about FPTR. We're really talking about declaring a variable that's going to be a reference to an object from class data. So that's why I kind of emphasize where should I put that star. I mean, even though the compiler allowed me to do anything, but the compiler really interpret the semantics according to this type of arrangement. So
it would be a better idea to put the ampersand sign or the star sign next to the variable, next to the type, because it indicates the type.
Right. That's what I meant. Yeah. Because it's really indicate the type. Yeah.
Okay, thank you.
You're welcome. I mean, there is I have seen some people do like this, all right, and just put a space there. It's I think it's a good habit. I mean, once you understand this, it's better for you to put it this way to remind you and remind others that this n sign or star is actually associated with the data type in this context. Yeah. I know it's confusing, but this took some experience and interact with the compiler to understand the semantics. Yeah. But on the other hand, I just want to tell you, this is probably the hardest topic in C++ programming. It's so confusing. Yeah. Okay. Any other question? Okay. I'm sorry, I have the time is up, and I'm sorry I run a little bit over time. And any last minute question before I close today's session? Okay,
I have a question. Professor.
sure, go ahead.
Are there any office hours for TAs soon, or do they have office hours?
Okay, I will ask the TA. I haven't talked to them recently. They should, each of them should have at least, I would say, 2 hours of office hour per week. Just like I don't know if you're coming to my office hour. I host about 1.5 office hour each on Monday and Friday. I will ask them to make sure that they arrange office hour for you guys as well. Okay.
Hi, Professor.
Yes.
We do have office hours, but we just haven't updated in the PL.
Okay. Okay. Thank you very much, John. And just let the student know, because I'm sorry I haven't talked to you, so I haven't catch up with exactly what's going on. All right.
Yeah.
Thank you.
Yeah, no problem.
All right. Any other last minute question? Okay. I hope you enjoyed the discussion and also the lecture, and I will see you on Thursday. Okay. Bye.